Hi, everyone. We'll get started in a minute. Welcome to our YouTube live session. We'll just let a few more people join in. All right, why don't we get started? So thanks everyone for joining. This is our last YouTube live session for grading optimization. We'll just do some quick introductions first. My name is Charlie Ogden. I am a product manager at Autodesk. I'm focused on grading and drainage features in our infrastructure products, Civil 3D and InfraWorks. We also have Val.
I'm Val Koch. I'm research engineer here at Autodesk. I'm doing anything optimization and grading optimization in particular.
And I'm John Sayer. I'm a technical marketing manager here at Autodesk. You might have seen me on some of the videos we produced for some of the new features, things of that nature on YouTube. So hello and good morning, good afternoon, wherever you are.
All right, great. So as you might see, this is part 6 of our 6-part series YouTube live Ask Me Anything sessions on grading optimization. We put these together so we could help users learn better how to use the grading optimization tools for Civil 3D. And under this video in the description, you'll find links to the earlier webcasts that we did. And I think at the end, I'll point out you can also get to a playlist. I'll show where that is. So we've added some other videos there, and in the future, we'll continue to add some stuff up in that playlist that you could watch later. I'll point out where that is when we're done. Yeah, so today we're gonna go over, talk about retaining wall grading in grading optimization, as well as point out some other things we haven't covered yet in any of these sessions. So yeah, with that, why don't we get started? John's going to start here.
All right, I'll go ahead and share my screen. All right, can you guys see it?
Yes.
All right, so as Charlie said, we're going to talk about retaining walls today. And the first demo that we're going to do or what we're going to talk about is actually benching. All right, so we've had several questions in the past about, can you do benching type grading with grading optimization? And yes, you absolutely can. Just a little bit about this data set before we start. This piece of property has got quite a bit of relief. You can see that there's a ravine that runs down through here. It takes water, things of that nature. So this, we've been asked to actually grade this and have level pads. I say level pads, mass grade it and see how high these benches are going to be at the back. So they're kind of teetering back and forth on whether to use retaining walls or to actually bench it with specific parameters. Okay. And this happens. I live here in Missouri, and if you've ever been to Branson, Missouri, everything is on a hillside. So we're always trying to figure out how to value engineer grading plans and how to, put things together to where it's not going to cost a ton to build it. And when you build retaining walls, there is a cost to that, but sometimes there's even a cost to benching itself, right? Because if you're in a rocky area, then you're gonna run into rock. You got to break that out, things of that nature. So we always kind of start off with the natural way of grading and using the benching, and then move towards retaining walls. That's what we'll do today. We'll do it on this same project. And I'm just going to quickly walk through how we set it up. So we start off, we've got our, and let me pick the contour there. We've got our grading limit. Okay, so our grading limit is like a typical grading limit that we've used in every one of these sessions. You have to have a grading limit in order to work with grading optimization. So you always want to have a grading limit. So it's going to be set to 0 for the min drain slope, and then the max slope will be 50. Okay, so 50 is 2-to-1. We can change that. All right, that's not a problem, but we'll leave it at 50 for right now, just to see where we're at whenever we run the grading. Now, what we've done is we have started at the edge of the property line here, and we've started to create our benching. Now, how did we create our benching? Well, we had to figure out what type of design we wanted for our benching. So we have a width between the benches, and we have a slope on the bench itself, things of that nature. And what we've done is we've created zones for each one of these design items, okay? So this is the top bench. If I select that, that is going to come down at 2-to-1 to the next bench, which is right here. And that's got a 2% or 0 to 2% slope across. So it's going to come down at 2-to-1 and go over 2%, right? We have to be able to drain the water away. There's been a lot of times where in training classes from the past where folks have said, well, can you make that flat? Yes, you can. But usually you want to try and drain the water away somehow. So even on the benching. So we've set that bench there at 0 to 2%. And then the next zone is the 2-to-1 slope again. And then we've got another bench area. And then we've got the last 2-to-1 slope for the bench. And then we would hit our grading limit. Okay. Now, we've also got how we want these lots to be graded. Okay, so what are the parameters for that? So inside of this subdivision area, we want it to go from 2 to 8%. Okay, so the min drain slope be 2% when it can obtain that, and then 8% at the max slope. So again, the great thing about grading optimization is the fact that these are the parameters that we're giving it up front. But we can always go back at any time, even in the optimizer, and change any of this data and just rerun it, right? So if we started off at 2 and 4, we could run that. If it's giving us benches that are way too high, or it's the cut fills just out of whack a little bit, then we can go back and change this and do it right on the fly and rerun it that fast. Okay, so that's the great thing about grading optimization is being able to iterate grading plans and give a customer or give a client of yours options. Okay, if they're stuck on a specific way that they want it graded, then you can grade it that way. And then if it doesn't work, you can give them an option to say, okay, well, we did it this way. Now we're going to do it this way. These are the 2 different options to pick from, and you've not spent a ton of time to do it. So now that I've gone through everything here and showed you how we've kind of set this up, then we can just run the optimization. All right, so I'm going to go to Analyze, and I'll select Optimize. And I will just pick, whoops, I didn't have any other surfaces in there, so it just automatically used my existing ground. So you can see that I've actually got another zone inside of this. Well, I'm going to turn that off. All right, so I'm actually going to select it if I can get it to pick, because the other zone. We'll just go through here and pick these zones until we find it. All right, I may already have it off. Oh, that's another grading limit. I was doing something else inside of this data set. So it is off. So it will not look at that grading limit. I'll just go ahead and toggle it off so that we don't see it. So we do have our grading limit that we're going to use in all of these different zones here. So I'm going to simply do this. I'm just going to simply hit optimize. Actually, I'm going to look at this, look at our balance, cut, and fill. I'm not worried about that right now. I'll hit optimize. And I'll kind of spin this around, and it will show you how it's grading. All right, so what we're concerned with is meeting the criteria in this pad area, okay? Yes, it'd be great if it balanced, but in this particular instance, we want a nice set of pad sites or overall grading. So that's why I'm not really all that worried about the cut fill. We can look at it and see how it's going to grade it here without the cut fill. Then we could go back and check the cut fill to see if it balances at any time. So again, you can start to see these benches. All right. So you can see the 2-to-1 slope down to the flat bench, 2-to-1 slope down to the flat bench, and then the 2-to-1 slope to daylight. Right. So it's created what we wanted it to create. Now, the great thing is it's already meeting the criteria here in our pad area that we want. Right. So if I hover over this, and I can't show you because for some reason, it's my monitor system that I have. It's putting it on my third monitor instead of my main monitor. So I can just tell you in this area, our max slope was set to 8%. Well, see, it's already fixed it, as I've tried to tell you. It was at 8.43. This area here where it's red, it's at 8.4%, right? So it's going to continue to work its way down. We can always watch our convergence plot and watch it as it travels down to this bottom of the graph, right? We can let this run for as long as we need to, but I can tell you that it does eventually go ahead and get rid of all of this in about 3 minutes. Okay, so 3 minutes to run a revolution or a version, I won't say revolution, but run a version of the grading for this property. I think that's pretty quick. All right. The setup time to do that, they're just closed polylines, okay, for the benching. All right. So you can I just use the AutoCAD offset to get my distances and then just tied everything together as polylines, just closed polylines. So we can watch that. This is, again, the benching method. We can go back and we can change a parameter to 3-to-1, right? So I could stop this. I could go back in here and look at my parameters, and I could say, let's make this 3-to-1. Let's go to the next bench here. Let's make this 3-to-1, and let's go here and make it 3-to-1. All right, and then hit optimize again, and we'll be able to see if the optimizer can achieve what we want. All right, that's just going to give it a little bit better slope so that you can mow that slope down. I don't know if I would want to mow that slope down, but you can. For all you folks that have ever been on a riding lawnmower and mowed a 3-to-1 slope, it's a challenge. So you can see that it's starting to utilize that 3-to-1 slope here, 3-to-1 slope here, and here, and it's moving that bench back and forth, okay? Or actually, it looks like it's moving back and forth horizontally, but it's really moving up and down vertically. And you can see that it does travel all the way around our project here, right? And give it 2 or 3 minutes, and it would have most of this. There would be hardly any red here. And to be honest, this red here that it's working on right now, it's at 9.5%. All right, so it's got a little bit of work to do to get it down to the max slope of 8%, but it's well on its way. So that's the benching method of working with grading optimization, or working with benching with grading optimization. Let's talk about the retaining walls. All right, so I'm going to flip to another data set. It's the same actual project, but it is set up with only a retaining wall. So how did we set this up before? Well, we had our grading limit. Again, it's the same grading limit that you saw before, okay? We also had our pad, I always call it the pad zone. because this is how I wanted to grade inside of this area, and that is right here. All right, so we're going to leave it, we're going to change the parameter a little bit now. We're going to go with a 2% min drain slope and a 6% max slope, okay? Now, we have set up one additional thing. So again, 2 zones that we've got right now, okay? The grading limit and the actual inside pad. We also have built another polyline that is this retaining wall, all right? And if you want to apply that, that's right here inside of your tool palette here. It's just another one of the grading objects that's there called retaining wall. All right. How did we set this up? Well, if I select that retaining wall, we're going to start with a 1-foot min height and a 10-foot max height on the wall. I know that there's all kinds of walls out there that are, shoot, we have them in Branson, they're 30, 35 feet, but a lot of times folks want to step those walls so that, you know, if you lose control of your shopping cart and it goes down over the hill, it doesn't fall 30 feet, it only falls maybe 10 feet before it continues down the hill. But we're going to start with a 10-foot max height, okay, and see what the grading looks like. See if it can achieve that 2% and 6% cross slope across the lots. All right. One thing I do want to point out, when it says when selected, the higher side of the retaining wall shows as a shaded line. What it's talking about, and it's a little bit difficult to see in red, but you can see it. The darker side is here and the lighter side is here. All right. That means that the high side of the wall is going to be interior to the lots, which is what we want. We don't want the high side to be over here. Believe me, if you forget, well, if it comes up and it's not reversed and it looks like this, you can simply reverse it. But if you forget to reverse it, when you run grading optimization or the optimizer, you will see it immediately, okay? And you can just stop and actually change this parameter inside of the optimizer itself. All right, so we'll just go ahead and select optimize. Now, I want to point out the fact, again, that I have 3 grading objects: the grading limit, the zone for the pad and how I want the interior lots to be graded, and the retaining wall. That's all I have. All right, so we'll hit optimize. I'll select my surface that I'm using for for it to grade 2, the existing ground. We'll go back to this corner here. All right, and I'll zoom in here. All right, and I'll just hit optimize. It does take it just a second to go through the pre-check. And here we go. It starts to raise the property up, all right, or the grading up. I apologize if you can hear my lab barking. I have no idea what he's barking at. But you can also see that retaining wall starting to move up, right? So it's going to move up to that 10-foot height. And notice that that pushes the actual pad area here back because it's using the global constraints that we've set of 3:1. That's that if it doesn't see the slope information inside of a zone, then it uses the global constraints. We have that set to 3:1. All right, so it's going to grade 3:1 here back down to the top of the wall and set that elevation. You can see that that wall moves all the way over and comes in right here. All right. And if you remember, I graded a detention pond in this area also in the pond class that we did, or the pond session that we did. I believe that was one of them I did. So we can see if I'm, you know, you could, it's pretty much done here. I can hover over this red and it tells me that that's 6.22%. And guess what? It's going to be gone here in just a second and meet the max slope constraint. And it's been running for what, 2 minutes? And we're at this point, right? And we added 3 grading objects. That's it. All right. And we can see what's going on very, very quickly. Now, what if I don't want this slope to be pushed back that far, right? At 3:1. And what if I want a shorter wall or a series of shorter walls? Okay. Then we can simply do this. We can stop the optimization. I can close this. And all we have to do is simply figure out what the distance is between the retaining walls that we want to have in a stepping system and just offset our initial wall. So I'm just going to use 5 feet. All right, we might use 10 feet. I don't know, whatever you want to use. Today we're going to use 5, and we'll just add one more wall. All right, now if I select the original wall, it's going to bring up my zone properties. If you offset that, just using a typical AutoCAD offset command and select that polyline that it offset, it does not have the grading object applied. So we would need to go in here and select retaining wall and apply it to that line. And notice that the outside line or the outside of this is shaded. So we need to turn that inside. Now, I'm going to go ahead and leave this at a max height of 10. So we'll have 2 10-foot retaining walls separated by 5 feet. All right, and just go right back to optimize. Now, I do want to point out this also. My retaining walls are linear, right? They don't have a lot of curves. That's the great thing about setting these up with polylines. You can create that retaining wall to meander back and forth. You can use curves, whatever you need to generate that retaining wall. We'll bring this back up. We will spin around to the same location. All right. And I've got my 2 retaining walls here. We'll just hit optimize. Right now, you can instantly see the 2 retaining walls moving back and forth. All right. So it's setting the height of this first retaining wall first is what it looks like it's doing to get all of this red and to match the parameters that we gave it for, or the constraints that we gave it for the pad itself. So it'll bring that up until it sets that height, go down 10 feet and bench it down to this next retaining wall. And notice that with the 3-to-1 slope with the global constraints, that retaining wall is not going to be that high at the bottom. So the 1 foot minimum and the 10-foot max, that really comes into play here. The 10-foot max is at the top and the shorter wall is at the bottom. Now we get over here and the wall kind of daylights right there. You know, it's not very tall, but you can see that it's starting to work its way back up right in here. Right, so Val and I were talking about this yesterday, and this is a subdivision. And you have children at play in subdivisions, and they always are over trying to get into things and could accidentally fall off of something. So we could make a series of these that are 3 feet high, right? Something to where if they fell, they didn't fall that far. But 3 feet can still hurt you, but that's a lot better than 10 feet. So we could stop it right here at this point, and we could go back to the retaining walls themselves. All right, and I could say for the top wall, I only want it to fall 3 feet. All right, and just hit reoptimize or just hit optimize again. It's going to reset the model. Actually, I want to stop it, and I'm going to go ahead and reset the model and then hit optimize. All right, it goes through and it starts, but this top wall is constrained to that 3 feet, right? So it's going to move, it's going to build it at 3 feet. And you're going to see this bottom wall start to get much higher, okay? But think about iteration, all right, in doing this in the manual method. All right, I say the manual method. Let's just talk about it through the lens of using the traditional grading tools inside of Civil 3D. Okay, if I was to offset that line and create a retaining wall, I would have to build another feature line. Then I would offset that feature line to give me the top and the toe, right? Well, if I go back and I adjust that to be only 3 feet high instead of 2, I've got to go back to my feature line and edit the elevations on the retaining wall. The thing about that is it's easy, right, to edit feature lines because we have the elevation editor and the dialogue and everything, and we can see exactly what it's doing. But if that retaining wall is actually sloping at the top, then we've got to go through and maybe adjust one of the feature lines and then do a stepped offset for the bottom, right, to retain elevations that are different going down that line. With grading optimization, it sets all that for you, okay? And it's going to actually return 3D feature lines with this whenever we send the optimized result back to Civil 3D. So you can see I've got my 3-foot wall here, and I've got my 10-foot wall down here, right? So if, what were we saying yesterday, Val? Little Johnny comes down the street and misses the turn and goes careening off. Hopefully he can stop in this area, right?
Unless he wears his bubble suit, right?
That's right. We said little Johnny because I physically have done that when I was a kid, fallen off things and done things. That's just part of it, part of being a kid. So bottom line, we can do this very, very quickly with grading optimization. So last thing I want to show you today is we've gone in before in different sessions, and we've used this Project Redtail data set, and we've graded this truck well. Okay, so we've had a lot of questions in the past about, I've got a truck well, how do I grade that with grading optimization? Okay, with retaining walls, it works very, very slick. Okay, so I'll explain how this is set up. This building actually has a reveal right here. So the building pad is going to be set to grade itself level with a pad, or level with the pad. All right, so it's going to set the finished floor for me. All right, if what I've done here is this is the width of the truck well itself. So if I right click, I can actually look at the reveal that I've added. All right, and that elevation difference is a fixed elevation of 4 feet, right? So that the truck can back down the truck well and butt the truck up to the actual concrete itself, and then they can move the product in and out or whatever they're hauling. Okay, so we created that reveal so that it would know that it's going to drop 4 feet. All right. Now that reveal, we then created the retaining wall around the outside. Okay. And notice which direction is shaded. Okay. Remember, the shaded side is going to be the high side of the slope coming into it, or the actual earthwork coming into it that they're going to grade. So the low side would be inside of here. That makes sense, right? Because this pad is going to start here at whatever elevation it's graded at, and it's going to drop to here, okay? So that retaining wall goes all the way around, all right? Then we have how we want it graded from the top of the truck well down to the bottom, right? And you can see I've got a stormwater inlet here. So when the water goes cruising down through here, it goes into the inlet and then comes back out into the detention. This is kind of typical. Maybe they might use a grate drain or something, but this is how we've set up this interior grading object as a zone. We're using a 1% min, 10% max. What we did do that was extra is we used this minimum drain inclination. And how we set this inclination angle is we select the pencil here, we pick the top of the zone and we move it to here, running a straight line down. That's the direction I want it to go. And it sets it the way we need to. Now, what that's done is it's telling it to grade that way. All right. It's telling it to grade northeast. All right. It's creating a break line. And that's all we've done to add that to it. Now, this is going to be taking into account for all of this grading that's going on. The thick, heavy lines that you see, these are grading objects that I've already set. So not only do we have the building pad, but we have drain lines going to the inlets. We have a slope going down to the detention pond. We actually have the detention pond, so on and so forth. So there's a lot going on in this grading plan, and it's going to carve this out for us as according to how it's being graded by GO. So let's go ahead and select, or let's go ahead and run the optimization. All right, and we'll zoom to this. And please, Charlie's going to start making fun of me because of my navigation skills. All right.
No, never.
I picked on him a little bit about turning things up in the object viewer. So he'll give me a session on how to navigate inside of GO. So first thing I want to show you here is we can always look at what's called the direction vectors to see, what did I do there? I picked the wrong one. To see how things are meant to be graded, or the how we've got it set up. So I can hit direction vectors and you can see the blue lines, right? Well, this area right here does not look like what our intent is. Okay, so when we change, this will reset and look correct whenever we go ahead and hit optimize. Okay, so don't think that this is how it's going to try and grade. It will reset this interior right here of the truck well whenever we hit optimize. And it'll reset the area or the arrow directions for some of this in the parking lot also. Okay, so I'm just going to go ahead and select optimize. And this will start to grade, and you'll see these arrows reset. See that? So I can see things are shedding away this way, coming this direction, and everything from this point back is going towards that wall. And you can see it's already starting to define. Right? We can let it run for 3 or 4 minutes. We would probably, since there's so much grading going on, I'll back up and let you see this entire site's working. Okay, it's grading this entire thing, the curb, the flow, it's using the drain lines to create the low points so that we can capture the storm water and get it out of there. It's grading this back area towards the detention pond, by the way. And if I zoom in, I can see that it's building my truck well. You can also see it's not only next to the building, but notice this, it's coming up and it's daylighting up to where it needs to. Okay. Same thing on this side. So all that did was just carve that out and tilt it towards the building at the 4-foot height that we gave it. And we used retaining walls to do that. And we used the reveal on the building. And then we told it how we wanted it to grade interior here. All right.
Actually, John,
Yeah.
I just want to say when we did that the first time, we didn't put this inclination direction on there. Instead, I think we put them in to 0.
Yes.
And then this became flat. It lifted the building up. It created the truck well, but it graded away from the building and they created a ramp that was flat. And then we saw that and we said, oh, no, we want actually some drainage in there. So that's where we then put this. That's important if you want the water to flow actually somewhere into the ramp and not out, or being flat is actually the worst you can have. So that's just important to remember when you build these ramps.
And again,
otherwise the solver is just going to lift things maybe and might even flow out of the ramp.
yeah, we've actually had that happen when we were testing things in the past. It would actually be flowing this way, and that means it's not things are not grading it's the way that we want and generating this inside. And Val is actually talking about this area here, the inclination direction. That's what we set in the beginning.
And one other thing was in the first webcast, just that you remember, if you set this min drain slope here to something bigger than 0.
Oh, wait a minute. Let me
Yeah,
pick it
that's
again.
fine.
There you go.
To 1, for example, and you wouldn't set this guy, then these blue arrows, they would just go to the closest drain line. So yeah, these guys would just drain down here, and maybe and you would have some weird stuff. So if things don't work like you want, you turn these direction vectors on, like John did, then you can see what the solver tries to do, and then you realize maybe, oh, I should have maybe done something here.
So we could return this back to Civil 3D and we would have everything graded in like what we want. This is a typical thing for larger buildings that have bays where tractor trailers back in. So I mean, it's a common thing to have to grade this in, and that's a pretty easy way to do that and have it grade in the truck wells themselves. And they come in all shapes and sizes, right? I mean, it may not be this long, right? It may be a shorter distance that we have to travel, but you can do that per that design or per the design of the project. So have we been having very many questions?
No, we're good.
Well, then Charlie, I think I'll go ahead and turn it on over to you. That's what I needed to show today.
All right.
So I will
thanks,
stop
John.
my share and let you take control.
Sure. Yeah, so we also wanted to look at some other settings we haven't really shown. Maybe another wall example too that shows some new stuff. But so first, one thing with, we'll use this site here as an example, but you know, we've had questions before. If you remember from the first webcast, we talked about how grading optimization works, and it's really, it's looking at the triangles in a surface, and it's trying to basically move the corners of the triangles, right, up and down. It's not moving anything horizontally. It's just moving triangles up and down, which is very different than what we're used to with other tools in Civil 3D, like the corridor grading, the grading, the gradings that we have that we can put in grading groups and grade from a feature line. All those gradings do projection grading. They grade out, usually, you know, either at a distance to target a certain elevation or target a surface, or they just grade out to, yeah, a certain distance. But so that's like projecting grading, and we're not really doing that with grading optimization. We're just moving things up and down. So questions have come up: how can you daylight in that case? So we wanted to show an example of, I guess, how you could daylight. And I guess before I get into it, what we want to do is turn on the option where we minimize the earthwork. Instead of balancing, we're trying to minimize the cut and fills. So what that'll try to do is make it not move the corners of the triangles up and down unless it really has to meet the constraints. But we probably only want to do that in the areas where we want to daylight. So what we're going to do is just kind of use this example here. And I think just initially, I'm just going to try and grade the building and the parking area. And just have our grading limit from before. So let me just add these, add the grading limit. Oh, it popped up on the wrong screens. All right, and we'll do 3:1, 33%. And I'll add, for the building pad and the parking, I'm just going to use zones for now. I'm just going to use the zones because, yeah, I want to grade outside of here. And for the building, I'm just going to still keep it flat. I'm not using the building pad because I don't want to get into the, you know, have it do like a wall kind of on the outside. I want it to grade on the outside. And the parking area as well. We'll just do 1 and 5. And what I'm going to do too is add a bounded point. So, I mean, I could grade this. The whole site's pretty flat. It probably wouldn't do too much grading of this. It just kind of flatten the building out, and it's already kind of flat around it. So you wouldn't actually see too much grading. So what I'm going to do is add a point. Not sure if we've really touched on points too much. But I'm going to add this as a bounded point. And what that'll let me do is give it an elevation. And it's inside this zone, and the whole zone's 0 to 0. So it wants to kind of flatten this out. But if I put a bounded point in here, it will try to raise this whole zone up to this elevation. Now, the bounded point could be just a single fixed elevation, or you could put in a range. either way for this, doesn't matter, but you have some options there. So what this will do, this will make it raise this zone up to elevation 90 as opposed to like 85 or 86 that it is here. So we'll definitely have some fill around the building. And then in the grading limit, actually, what we wanted to point out was these options here, which I don't think we've even looked at before. But if you remember, once I get into grading optimization, there's 3 objectives that we can grade for. The ones we've done quite a bit on is smoothing the surface. So that's really what smooth the surface is trying to do, is just get adjacent triangles to use the same slope. And then balance, cut, and fill, of course. But I don't think we've done too much with minimize earthwork. But this is the option that will just try not to grade unless it has to. And what I'm going to do for this grading limit is actually turn these other 2 off and just let it work on minimizing the earthwork. If I have it smooth the surface too, then it's going to smooth everything out outside of the building and the parking area and not really give me like a real daylighting. But if we only have minimized earthwork, it's going to raise the building and then only grade around the building so that it basically daylights to the surface around it at this 3-to-1 slope. So with that, let's just go to grading optimization and see what that does. So first, let's just take a look at the objectives here. I'm not going to balance them. I have minimize earthwork on. I just have it at 1. Not sure. This is pretty strong, so you don't really even need it all up at 100. And some smoothing that'll happen, for the rest of the grading. But smoothing won't happen in just the grading limit area. So this orangish area, it will happen in the 2 zones that I have.
You could actually even turn the balancing on, and then in the zones, you could turn it off as well, right? It's like you put filters on top of, this is your base configuration, and then you can just filter these things out in the zones. We never showed that in previous webcasts.
Yeah, good point. All right, so I'll just run this for now. So here you'll see it's raising the building up and down, raising the parking, and then it's just doing this 3-to-1 around the building. Oh, and I thought I had this set differently. So let me just stop this for a second. What I was going to point out was I thought this was going to be set to the default, which is more like this. So in preferences, I don't think we've gone in here too much. This is basically the default setting for this, mesh quality medium, refining on. Let me just run this for a second just to show the difference. So I'll just stop it there. So you'll see just doing that, you're not really getting good daylight around either of these objects. And the reason for that is it's just looking at these original triangles. And it's just raising and lowering the corners. So if you have large triangles, even large skinny triangles would be worse. You get some weird grading happening out here. So what I had done, and you've already seen it, but I had turned on a maximum triangle size. And I just put in some small number. What that does is break these triangles up into smaller triangles, which you kind of need to grade it more smoothly around the daylight area.
And you had
Yeah.
it to high, no? The quality? Or is
Yeah, I
that-
did have it to high too. So the mesh quality will try to, I guess, remove long skinny triangles, have a more balanced shape to the triangles. So I'll optimize this now with the triangles turned on. You'll see it retriangulates to much smaller triangles. That's how we got, and I thought I was gonna have it set the other way first, but yeah, that's how we got kind of a smoother daylighting happening around there. All right, so anything else to point out on that value thing?
I don't, maybe, do you want to try to balance between the parking lot and the building? See if that works.
Sure. 'Cause
But you would have to go, yeah, there, yeah.
it's just, it puts my parking lot in the hole though.
It's-
Because they told it to raise the building with a bounded point, right?
Not very useful, but funny to watch. It's digging out on one side and filling up on the other.
Next, you're gonna have me build a pyramid, right?
Yes. No. John wants to do that.
Yes, that's a typical project, right? Pyramids, everybody's building pyramids these days.
All right, so yeah, so that's a little bit of, you know, some of these other, the preference options over here. In the grading limit, using these to turn off other objectives that are being used. And like Val pointed out, you could also do that in here for any of the zones. So here's the building zone that I had. You could expand that as well. Maybe turn off balancing or smoothing there.
That's actually useful if, for example, you have a site and you have, well, I guess you could have different grading limits too. Well, I didn't know what I want to say, but if you have like a wind farm or a solar farm and you have different patches where you want to balance between the different grading limits, there you would turn the balancing on. In between, it wouldn't do anything, but there, yeah, actually, you don't need to turn it off here. Sorry, I was just a.
Yeah, okay. So yeah, that's it for that. So just, yeah, ways to turn off objectives in some zones. And let's see, do we have time for one more?
Sure.
Quickly.
One other
yeah.
thing we wanted to look at was John showed retaining walls. There is a sample file with grading optimization, this bridge abutment. It's set up to grade the walls with zones, but now with the retaining wall feature, we can do this a little bit differently. So this is a bridge, proposed bridge going over a highway. There's a grading limit here, so let me just add some objects here. So, whoops, I don't want to open this one to create a grading limit. So just grading in this area around the bridge. And where the walls are, there's actually AutoCAD solids here from InfraWorks. Right, so there's a couple of abutments there. So we've already created some line work for retaining walls along within these abutments. So there's 2 of them here. Select, sorry. Yeah, that's the wall. I'll select similar, so these are all on the same layer. There's one. Here's the other. And I'm just gonna add these as retaining walls. And just make sure, like, the bold line is the front face, the low side of the wall, like John pointed out, and the shaded area is where the side the wall is actually on. So that should be to the back, and this one down here looks like it's reversed. So I'll just flip that one. And we do have, so this is my grading limit, but we do have like a road coming in here that's already been graded with this surface. I should point out, this was the surface that came back from InfraWorks. You can see it's grading the road, it's grading side slope, but then down here where we actually want an abutment, it's just grading underneath kind of square with the perpendicular to the road, even though clearly that we want it to go at an angle. So InfraWorks itself can't really do this grading. So that's why we're kind of doing it here. So we don't really want the contours to look like this. We want them to kind of tie into our wall. But we already have the road, and the road's good. So there's an area here and here for the road that we're going to use an exclusion zone because we don't want it to regrade those areas.
Somebody was actually just asking that question, how you can make geo not touch corridors or things that you already graded. And we showed that in the last webcast, and this is exactly the trick. You draw an exclusion zone where you want geo not to touch it. So.
And then I guess just we want to flatten out. I mean, we could probably grade this a little bit better, but we're not really too concerned about the grading also here in the highway area. So I'm just going to create a zone just to basically flatten this out for the purposes of this demo. And I'm just going to say 0 to 3% or something. And so that'll flatten this out, but I also want to make sure that this is lower. I don't want to just smooth with the area of the road up above. I want to make sure this is kind of at the right elevation. So I'm going to add another bounded point, which actually I already added an AutoCAD point here. So I'm just going to add, like I did before, bounded point to that. This could be an Civil 3D point too. It doesn't need to be an AutoCAD point. And let's see, just put a range on this. 707 to 710. That way, make sure the area down here stays around 707 to 710, whereas the elevations up here above the bridge are 717 or so. So that'll force it to want to put in a wall here. So I think I got everything. So I'm just going to optimize this. And you can see, you know, there's the InfraWorks grading coming around underneath the bridge. But you can see where my retaining walls are because the road goes this way. So of course that InfraWorks grading doesn't look like it's going to work well. So now I'll just run this. You should see it start to put in those walls. Try to keep, you know, it keeps the road elevations in the exclusion zones like they were, and then grades the wall. there is a lot of red in here. I'm just trying to get that to flatten out though.
Struggling on the daylights a little bit too. What's your
Oh,
max slope there?
oh, that's right. These should have been 36 is what was graded.
Oh, it's 33. Yeah.
Yeah, it was already 36 coming from InfoWorks, so should struggle if it doesn't go flatter. So now it's, you could see instead of the contours bumping way out, they're going and tying into the wall here. Tying in on the other side too. Keeping them out of the highway area. And I could probably play around with this, resolve some of the other red, but for purposes of just showing how this works, I think that's pretty good.
Yeah, in a nutshell, in the older version, what we did, we used these zones, and then we used a whole bunch of elevation offset points to make sure that the wall doesn't touch the bridge. Now it's much simpler. You put this retaining wall in, you make a zone in front so that it keeps it down on the ground. That's what Charlie did with the 3% max. And then you just put, like what John did in the first example, you put a maximum height of that wall, and you make sure that this maximum height is just below the bridge so that it doesn't touch the bridge, and you're done.
Yep, cool. And then if I grab the bridges here, my surface, grab bridge 2. And then the object viewer. Still lessons from John. You can see now here, so the grading's coming down on the road, and then just kind of tying in to the abutment, and then it's low enough for the highway underneath. So you could, this is now a surface you could bring back to InfoWorks as well, just to show better grading there. The other side as well. So all right, so that's that. That's all we wanted to show. Let me just point out, show that. So if you go to our channel, you may have seen there's a playlist just for grading optimization for Civil 3D up on the Autodesk Infrastructure Solutions channel. You can get to that playlist directly from this link, or just go to the channel, look at the playlists. There's a number of, I'll just open it, but there's a number of videos up there already. This webcast series is up there. I think we have part 5 to add, and then this one, once it's done. John did a series of videos last year. Those are up there. And then also a recent productivity study has been added. And we plan to add some more videos to this playlist as kind of new stuff comes up or things we want to show. So they might not be a live session, but we'll at least continue to post some videos there. So with that, I think that's all we had.
Charlie, you
guys,
wanna-
were there any questions left?
Nope, I think we've taken care of all of them. Charlie, do you want to think we should do a quick shout out for Angel's 30-minute workout that he's going to do?
Yeah, go ahead.
He's I don't know if you all know Angel Espinoza. You've probably seen him on the 30-minute workouts that him and Alan Gilbert and Jerry and Jeff Bartles do. He is going to have a session on Thursday and it's everything grading, different ways and different methods to grade things in Civil 3D period. And he is going to touch on grading optimization also. So at least that's what I've heard. So those guys all do great presentations. If you haven't signed up for their web series, please do. You will do nothing but benefit from it. So just wanted to throw that out there to continue on with the whole grading theme, which is what we will end up doing here.
Cool. Yeah, if you haven't heard it, here's where you can find the page to sign up. All right, so yeah, nothing else.
I don't have anything.
Cool. Well, all right. Thanks everyone for joining. Again, this will be saved to the channel, saved to that playlist. So you guys could go back and watch it, share it with other users at your offices. So yeah, thanks again. Thanks for your time joining. And thanks to everybody in the background helping us out, get this set up and recorded and everything. Hopefully we'll talk to you again soon. Thanks.
Yeah, thanks everybody.
Thanks, everybody.